What's going on, everybody, and welcome to a Python Plays GTA 5 tutorial series. So in this series, what we're going to be doing is just simply exploring the open world of Grand Theft Auto with Python, seeing what we can come up with and what we can do. The truth is, I really don't know. The only thing I've done for this entire series is just make sure it's possible. So I wanted to make certain a few things. One thing is that we can just process frames quickly enough. So if we can only process frames at like 1 or 2 frames a second, that's probably not going to be good enough to really do much at all in this game. So I was really kind of hoping for at least a 10 plus frames per second process rate, especially if all we're doing is just trying to get the frames into Python. Because then we're going to, in theory, need to be running algorithms and all kinds of stuff. So that was one thing I wanted to confirm. And the other thing I wanted to confirm was that we could actually control Grand Theft Auto with Python. I was pretty sure we could just use send keys or PyAuto GUI, but I wasn't positive on that. As long as we could do those two things, I knew that, okay, we can actually do this project. So I have confirmed those two things in advance. Otherwise, really nothing else has been confirmed. So this is just going to be a series of me running through, and if you guys have suggestions or improvements, I'm all ears, because this is just going to be filmed as I go. With that, I also created this GitHub repository. By the way, just in case you don't know, you can go to github.com/Python programming, and that's most of Python programming.net's source code. Also, usually I post source code on pythonprogramming.net, but I'm going to put this repository here, which is github.com/syntax/pygta5, and here you can find all the code step by step that we do and the latest version, although right now I don't really have that up there yet, just because we're just kind of exploring at the moment. So if you have improvements or whatever, you can do a pull request, submit your changes or whatever. So anyway, yeah, so feel free to contribute your ideas and all that, and if they're good, we'll just incorporate them to the entire project. Now, with that, most of the code here is going to be just the first pass through. Even the code that I've already tested to make sure it works, that's just kind of like a really quick run through. Nothing's going to be very pretty. This is going to be messy and probably not beginner friendly in any way. So anyway, let's go ahead and get started. So what I've done is we're going to use GTA 5. You don't have to use Grand Theft Auto 5. You can use any other game. The first few, first of all, the method that we're using to get the frames, you can do with any game. And the method that we're going to use to send input, you can probably do with most games. And then some games might even get by with just send keys or something like that. Other than that, you can probably switch around. Where the first kind of project I want to try to do is just do a self-driving car. What makes GTA 5 a really great environment is that using mods, we can control the time of day, the weather, traffic conditions, everything. It's a really cool sandbox environment that we can very quickly manipulate. Unfortunately, right as I started to record this, I'd found that there was an update to Grand Theft Auto, and every time that happens, you have to get an update to the mods. So anyway, I'm waiting on that, but we're not going to really need them for this one anyway, just because this is just some of the first few. But just know in the future videos, I'll probably be using at least the native trainer just to get started. Also, if you are going to follow in Grand Theft Auto, I am on just a little scooter. The reason for that is because there's no like first-person view when you're driving a car. So, I mean, there is, but it's not the car's like, what I would like is the car's first person, not the person's cockpit view, just so we can very clearly see the lanes, whereas when we're in the cockpit view as, like, in the first person view, you really can't see the lanes. It's really challenging in that view. And then you can go behind the car and see the lanes, but I wasn't really sure I liked that either, so this is the way I'm going to do it. I'm just on the scooter, because the scooter has full view. You could do a motorcycle, but the motorcycle's just probably too fast for anything we're going to be doing. Anyway, okay, yeah, so let's go through, like, the method for actually pulling in the actual screen and all that. So the first thing that I wanted to do was I wanted to research, okay, how do you actually capture a screen with, Python, and most likely in OpenCV, because we're going to need to use OpenCV most likely. So with a little bit of Googling, I found this page here, and the solution that was picked was this one. So the first thing we'll do is I'm just going to copy and paste this solution. Just copy that, come over here, paste. And so the first thing we can do is just run this solution and see what happens. Oh, no module. Okay, so the first thing that we have is, for whatever reason, image grab is part of PIL, so you would do from the Python imaging library. So from PIL, import image grab. And if I recall, they've made another mistake somewhere. We'll run it again anyway. Yeah, UNTA. So that's kind of off the screen, but let me just pull this over. So here, UNTA is being treated like a variable. I'm not really sure why they've done that. They must not have run the code before they submitted it. Okay, so that grabs my entire screen, which is a 4K monitor, so that's a problem. So, so we're going to close this. And the first thing that we can do is throw in the size. So image.grab. Through image.grab, we can pass a parameter here, which is bbox. So bbox equals, and then here we can specify the location. I'm going to do 040, 800, 640. And we're doing 40 just to handle for the title bar here. So I'll run that again. Move this out of the way. And here we go. So there we have at least something that looks good. I'm going to pull this up now. And the frames per second aren't looking too hot for us. So the next step is to see if we can't speed up the frames per second here. So the first question I wondered was, like, is it possible that, you know, showing the screen is what's taking a while? So one thing we can do is just simply cut that out, and then we can import time, and then we can say, basically we can say last underscore time equals time.time, and then while true, we'll just come down here for every loop, and we'll say end time, or rather what we can say is, we can just do a print. So print loop took something seconds dot format, and the format will be time.time, so the current time minus the last time, whatever that is. And then after we've done that, we need to update the last time. So then we'll just say last time equals time.time. And let's run that now. So we can see that the loop is still taking about not a half a second, but we're coming up, it's just not very good. So the next thing that we're going to do is, let's close this out. And so it's definitely not the show that's taking like a lot of processing. It's got to be something else. So I'm going to uncomment this. And then we have to wonder, and in fact, actually, let's leave that commented out, because the next thing we're going to try to do is handle, like if it's this reshape. So let's do this. Save and run that. Okay, and so this is so much quicker. So we can see that the line that's being bad to us is this reshape line. So what if we try to just, let me make sure this is on screen. Sorry, because there's going to be so many windows, so there's probably going to come a time where I'm going to do something that's off screen, so I apologize. But anyway, I'll do my best. And the source code will always be up somewhere. So I'm going to uncomment out these lines, and the window that we want to show, the imshow, is actually just going to be the print screen pill, so we can just paste that in. Let's run this. Okay, so that's not a NumPy array, so it wants it to be a NumPy array, but I do again have to wonder, is it the NumPy array that's taking time? Is it the pill.getData? Is it the dtype possibly? Or is it the reshape even? So another thing that we could do is we could just get rid of the reshape. So we could just come up to here, delete that. Let's keep print screen NumPy, paste that in. Let's run it again. Oh, got invalid syntax. Did we not close something, or did we close too much? Oops. Okay, close too much. Interesting shape. Okay, so, and it's also very, very slow. Okay, so I'm going to close that. All right, sure. Okay, so a couple problems there. Now, the next thing that we could try is, okay, what if we just did, rather than pill.getData, like that might be just a different format. The next question is, what if we just do numpy.array to print screen underscore pill. Right, and there we go. So now, the updates, we're getting more than 10 frames a second. That's, oh, the color is off. I was like, that's weird, this is red and this is blue. Anyway, we can talk about that in a moment. But anyway, okay, so now we have live updates, and sure enough, we could just move this over, and then we could, let me make sure this is sort of on screen. I'll just put it, I guess, here. It's a little large, but it's okay. So now we can kind of look around now, and we can see that this has made a huge, huge improvement over what we had before. So that's great. We can definitely work with that. Obviously, again, the colors are off, but that's just because we're doing like BGR to RGB. It's just not the way you want it necessarily. So now that we've done that, the next thing for us is to see about simply, oh, did I close what we were just working on? Did I just do that? Darn it! Let's see, I think I want this. And then let me pull this back up. Okay, so the last thing that we can do here for the image show, what we can do is we can actually convert this to the proper colors. So we can say, rather than np array print screen pill, we can do cv2.convert color print screen pill, and then we convert that to cv2 dot, oh, it is on screen, nice, color underscore bgr, so blue, green, red, to RGB. Okay, and let me make sure that's all good. And also, let's go ahead and just np.array. Let's just convert the numpy array here. Let's call it, rather than print screen pill, let's just call it screen. And then down here, we'll just say screen. Cool, save that, run it. Oh, okay, this is gonna be a challenge. Okay, there we go. All right, now it's the proper colors. We can look around, and everything's good. So this is a good first step for us to know that, okay, yeah, we're getting a little over 10-ish frames a second, but probably very close to 10 right now. So that's good that we can work with that, and then hopefully the extra processing that we do will keep us somewhere near 10. Because I'm guessing the most constraining thing is just this huge array that we've got to like pass through and do any conversions on. So like if you were going to feed this through a neural network, obviously you're not going to feed it 800 by 600 through a neural net anyway. So anyway, all right, so that's step one of likely many steps, but we've got the screen, or the actual visual data coming in. In the next tutorial, what we're going to do is try to do some typical OpenCV tasks for just simplifying the image significantly, and then maybe even doing a little bit of analysis. And then also we still need to actually send input to the actual screen. So that's what we're going to do in the next tutorial. If you have questions, comments, concerns, suggestions, improvements, or whatever, let us know. If you can help us get a better frames per second, that would be wonderful. I think the problem though is that we're basically processing these on the CPU, because obviously the actual game itself is on the GPU, but this whole OpenCV window is all CPU generated. So I'm not really sure I'm not sure who else is going to get the same frames per second as me. So I apologize if no one else is getting close. Anyway, yeah, so I will see you in the next video.